Hello grade 10s, welcome back to another exciting video. So in today's video we will be doing chemical bonding. Don't forget to like, comment and subscribe to the channel. Please share this video with your friends and family. And guys, without wasting any more of your time, let's get into the video. But first we need to know what is an atom before we can do chemical bonding. So let's look at what is an atom. So an atom is an element. Okay, the elements you see on periodic table, that is an atom. So an atom has a circle called the nucleus. Now in the nucleus we find positively charged things which are called protons. They're positively charged. And you also find, this is something, let me use a different color. This thing is a neutron. Neutrons. Okay, inside the nucleus you find protons and neutrons inside the nucleus. Now apart from the first layer, which is the nucleus, we have outer layers. So how do we get outer layers? This can be, let's take for instance that we have another outer layer like that. In this first layer we will have things like this. Okay, we'll have something like that, and those are electrons. So they are negatively charged, negative, negative. So they are electrons. And then we can have maybe another layer like that one, and then we have probably two electrons on this one. So the electrons on the outer layer are called valency electrons. In the inner circle, they are just called electrons, but in the outer one they are called valency electrons, and those are the ones that connect with elements connect with valency electrons, not electrons. Okay, so you have to know that the valency electrons are the ones that get exchanged between the atoms. So let's look at the periodic table and try to do something practical. Anything on the towards the right hand side, we have of that dotted line that I've drawn, zigzag, we have non-metals, and then on our left hand side we have metals, and then these ones that are in the middle here are transitional non-metals. Okay, so let's say for instance that we are trying, let's draw an atom for maybe sodium. Sodium is Na, so let's take sodium. We're going to draw the atom for sodium. So this is Na, which is sodium. Then we're going to have the inner parts, the nucleus, and then in the nucleus we will have the neutron. This is the neutron, and then we will have the proton, which is negatively charged. Okay, now let's look. This is how you do the first layer. We cancel hydrogen and that we cancel those two elements in the first layer to get to sodium. So we are going to cancel those two. And this is how we'll do it. We'll do the first outer layer and then have 2 electrons which are negatively charged, as I've said. So that's number 1. And then let's look if how much we have to, how many atoms we still have to cancel on the next. Now on the second row we cancel 1, 2, 3, 4, 5, 6, 7, 8. So we cancel 8. We cancel 8 to get to that one. So you saw them, there were 8, right? So the second layer we have 8. So we're gonna have 1 here, 2, 3, 4, and then that's 5, 6, 7, and 8. Those are electrons. Remember, they are all negatively charged. Now we still have the last row to get to sodium. Now in this last row we cancel 1. The one that we cancel, it's the sodium. So here we will just have this outer one and then just write 1. So meaning it has 1 valency electron, but the purpose, the goal is for it to have 8, which means it should be fully surrounded. So what you have to know is that all metals lose their valency electrons, but metals gain valency electrons. Okay, metals gain valency electrons from non-metals. So whenever we are bonding a metal and a non-metal, maybe we are bonding B and Na, we are bonding them. Na has 1 valency electron. B has how many? 1, 2, 3. B has 3, while Na has 1. Okay, for the one for the Na, let me represent it by the dot. Na has 1, while B has 3. So Na, because it has 1 and B has 3, Na will give up its own electrons for B. Okay, so this one will go to B, so that B can at least have 1 more, like that. So that B can at least be fully saturated like that. So, and this one will have no valency electron. Now let's get back to chemical bonding. So when you look around you and what is made of, you will realize that atoms seldom exist on their own. More often, things around us are made up of different atoms that have been joined together. So when you join 2 atoms together, this is called a chemical bonding. So chemical bonding is one of the most important processes in chemistry because it allows all sorts of different molecules and combinations of atoms to form, which then make up the object in the complex world around us. So what happens when atoms bond? A chemical bond is formed when atoms are held together by attractive forces. Remember what we said, metals are slightly negative compared to non-metals. Non-metals are negative. They have a lot of valency electrons that makes them more negative than the one that has few valency electrons. Okay, that's what you should know. So the one that has they attract each other. So the more the more negative one attracts the positive one. So we'll say it's positive when it has less valency electrons. So the opposites attract. So that's how atoms bond. They come together. So a chemical bond is formed when atoms are held together by attractive forces. So those attractive forces, we mean the one is slightly negative and the one is slightly positive. Okay, this attraction occurs when the electrons are shared between atoms, as I have shown you previously, or when electrons are exchanged between the atoms that are involved in the bond. So the sharing or exchange of electrons takes place so that the outer energy levels of the atoms involved are filled, making the atoms more stable. So when an atom is fully surrounded, it has 8 valency electrons, it is more stable. Okay, so if an electron is shared, it means that it will spend its time moving in the electron orbitals and around both atoms. So if an electron is exchanged, it means that it is transferred from one atom to the other. In other words, one atom gains an electron while other loses an electron. So this is a definition of chemical bonding. You should know a chemical bond is the physical process that causes atoms and molecules to be attracted to each other and held together in more stable chemical compounds. So the type of bond that is formed depends on the elements that are involved. So in this chapter, we will be looking at 3 types of chemical bonding: covalent, ionic, and metallic bonding. So the first, we'll be looking at covalent bonding, the nature of covalent bonding. So covalent bonding occurs between the atoms of non-metals. When you take 2 non-metals, as I have shown you, the ones that are metals and the one that are non-metals, and bond them together, we have what we call covalent bonds. So guys, carry this information into grade 11 because you will really need it. Okay, so yes, atoms bonds, when you take a non-metal and a non-metal like carbon and oxygen, they are both non-metals, or nitrogen and oxygen, both non-metals, you bond them together, they form what we call a covalent bond. So the outermost orbitals of the atoms overlap so that unpaired electrons in each of the bonding atoms can be shared. So by overlapping orbitals, the outer layer shells of all the bonding atoms are filled. The shared electrons move in orbitals around both atoms. As they move, there is an attraction between these negatively charged electrons and the positively charged nuclear. This attractive forces holds the atom together in a covalent bond. Let's do an example. Now we're going to bond C and O. Okay, so that is what we're going to bond, C and O, which is carbon and oxygen. So let's look at how many valency electrons that does carbon have first. It has 1, 2, 3, 4. So carbon has 4 valency electrons. So remember, carbon has 4. Now let's see how many oxygen has. It has 1, 2, 3, 4, 5, 6. So oxygen has 6. Yeah, so we're going to take carbon and say it has 1, 2, 3, 4. But then oxygen has 1, 2, 3, 4, 5, and 6. So oxygen wants to be fully covered, fully saturated. It needs 8 valency electrons. So carbon is going to give oxygen some of its valency electrons. So this one will go with this one will go with that one, so that and then we can write them like this. This is C. It now has 1, 2, and then this ones we'll write them in here that are going to connect with the O. Then we'll have O here. O has 1, 2, 3, 4, 5, 6. Yeah. Let's erase this ones so that we can have, oh, see the two that are bonding, we have them that side. So these two are bonding. The C is giving its two to this to the oxygen here. Okay, so that's what will happen. The C will give its valency electrons to C, and then C becomes more negative while O becomes more negative because it has gained more negativity. So this is what we call a Lewis diagram, which we'll do more in the next video. Now we're just handling theory and understanding our work. And this, guys, is a double bond. But if carbon was giving oxygen 3 valency electrons, that was going to be called a triple bond. So this one here is a double bond, 2-2. But if it was another 3 here, we call it triple bond. So that is a covalent bond, and a covalent bond is a form of chemical bonding where pairs of electrons are shared between atoms. And then we have single covalent bonding, as covalent bond, as I've shown you, is formed when 2 electrons are shared between the same atom, the same 2 atoms, 1 electrons from each atom. And then we have a double covalent bond is formed when 4 electrons are shared between the same 2 atoms. So a single atom is when, if oxygen was just getting needed one valency electron, it was a single from the carbon, it was going to be a single covalent bond, but it needed 2, so it was a double covalent bond. If it needed 3, it was going to be a triple covalent bond. Is formed when 6 electrons are shared between the same 2 atoms, 3 electrons from each atom. So you should also have noticed that compounds can have a mixture of single, double, triple bonds, that an atom can have several bonds. In other words, an atom does not need to share all its valency electrons with one atom, but can share its valency electron with several different atoms. So we can have 2 oxygens, not 2 oxygens, yeah, we can have 2 oxygens and 1 carbon, and then the carbon will share other 2 valence electrons with the other oxygen and share the other 2 with the other oxygen. So that one can happen as well, as it has happened on this example here, where is carbon dioxide. So we have 2 oxygens and 1 carbon. The carbon is in the middle, it has the X's, so the X are bonding with the 2x are bonding with the O this side, and then the 2x are bonding with the other O the other side. And then definition of valency is the number of electrons in the outer shell of an atom which are able to be used to form bonds with other atoms. So that is a valency. So it's the number of electrons in the outer shell of an atom which are able to be used to form bonds with other atoms. So yeah, that is what it is. And then and now we're going to go with properties of covalent compounds. We also have compounds. Covalent compounds have several properties that distinguish them from ionic compounds and metals. These are the melting and boiling points of covalent compounds are generally low than those of ionic compounds. So melting covalent bonds Covalent bonds are the weakest bonds. Know that covalent compounds are generally more flexible than ionic compounds. The molecules in covalent compounds are able to move around to some extent and can sometimes slide over each other. In ionic compounds, all the ions are slightly held in place. So covalent compounds generally are not very soluble in water. For example, plastics are covalent compounds and many plastics are water resistant. So covalent compounds generally do not conduct electricity when dissolved in water. For example, iodine dissolved in pure water does not conduct electricity. Now we're going to look at ionic bonding. So the nature of ionic bond. Electronegativity is a property of an atom describing how strongly it attracts or holds on to electrons. So the lower the electronegativity, the electronegativity shows how strong an atom can hold on to electrons. So ionic bonding takes place when the difference in electronegativity between the two atoms is more than 1.7. This usually happens when a metal atom bonds with a non-metal atom. When the difference in electronegativity is large, one atom will attract the shared electron pair much more strongly than the other, causing electrons to be transferred. So what is electronegativity? Is this number here. Electronegativity is this smaller number on the periodic table, this one. That is your electronegativity. Let's take electronegativity of magnesium is 1.2, and then the electronegativity of maybe fluorine is 4.0. So 4.0, fluorine can hold on to its valency electrons because it has a high electronegativity than magnesium. So magnesium will lose its valency because it has low electronegativity. So when you add those electronegativity number, they should give you a certain number for them to be a co-ionic bond. So here it says it's an ionic bond when you add, then electronegativity is more than 1.7. So when you add 0.2 plus 0.4 and it gives you more than 1.7, then when you bond them together, we say they are an ionic bond. So the definition of an ionic bond is that is a type of chemical bond where one or more electrons are transferred from one atom to another. So we have a crystal lattice structure of ionic compounds. So ionic substances are actually a combination of lots of ion bonded together into a giant molecule. So the arrangement of ions in a regular geometric structure is called crystal lattice. So in fact, NaCl does not contain one Na and one Cl ion, but rather a lot of these two ions arranged in a crystal lattice where the ratio of Na to Cl is 1:1. So they are equal. We have the same amount of Na and the same the amount of Na is equal to the amount of Cl atoms. And these are properties of ionic compounds. So you can read that. Now we're in metallic bonding. Nature of metallic bond. The structure of a metallic bond is quite different from covalent and ionic bonds. In a metallic bond, the valency electrons are delocalized, meaning that an atom's electrons do not stay around that one nucleus. In a metallic bond, the positive atomic nuclei are surrounded by a sea of delocalized electrons which are attracted to the nuclei. So a definition of a metallic bond. A metallic bonding is the electrostatic attraction between the positively charged atomic nuclei of metal atoms and the delocalized electrons in the metal. So positive atomic nuclei surrounded by the localized electrons, and then ball and stack model of copper. These are the properties of metals. Metals are shiny, metals conduct electricity, metals conduct heat, and metals have a high melting point. So this is metallic bonding. Yeah, so we've reached the end of this. So this is the chapter summary. What is a chemical bond? A Lewis dot diagram. I showed you a bit of it. Covalent bonding, a double or triple bond. What is a valency? A covalent compound, an ionic bond, and all of that. So we are done with chemical bonding. We'll just go into the practicality of it and show you different types of bondings in practical in the next video. Until the next one, bye.